And then what the next set? What's the next set? Let me see. Here is my set of natural number. And then don't write this down. And then outside we integer, including 0, -1, -2, -3, right? I didn't talk about the whole number. Whole number includes 0. And then what else? Set of rational number. Do you know Q? What's Q stand for? Quotient, right? Rational quotient division. And then outside of that would be set of all real number. And then the very unique set that compose all the set. Can you guess it? What is that? Set of complex number. The complex number include real number and imaginary number. It's just a picture of you how mathematics works. Right? We start from the smallest set, and then we kind of move out there. A union of sets. A union B is a list of elements in both set A and set B. So let me give you an example. What I meant by that. If I say A is the set of number 5, 7, 10, 15, and B is the set of say 4, 8, 10, 11, 15, then A union B, that little capital U, this stands for union, is all the elements that in both set A and set B. So everything together, right? All of it. Think of it like joint account. So 5, let me start from smallest to largest. So what everybody, so 4, we have 5, right? And then what? We don't have 6, we have 7, and then we have 8, there's no 9, but we have 10, 11, and 15. We don't have to write 10, 15 twice. So you understand union now, right? Union is the list of all two set together. Minus the duplicates. So you don't. So for union, do you say you'll get bigger or smaller? For union, your set get bigger or smaller? Bigger, right? You get bigger. Joint account, right? Hopefully, get somebody has some money here. You join together, you have more money. A intersection B is a list of elements that common in both set A and set B. So for example, if I'm gonna give the same example here. I'll use same A and B up there, okay? So A union B. I'm sorry, A intersection B. What is the common element in both A and B? Yeah, 10 and 15, that's it. So intersection is the set gets smaller, only the common. Say your friend, you go out a movie, here's a list of your favorite movie, here's a list of his favorite movie, and then you get a common ground, which movie you watch, right? So that's it. All right, now we go to the real deal. Let f and b be the function with domain a and b. So the domain of f, we're gonna call that the set of the set of all numbers that satisfy f. Right? We call that set is a, and then the domain of b is the set of all numbers that satisfy g. I mean, it doesn't make it undefined. We call that b. Right? Then the sum of f plus g, the difference f minus g, the product f times g, of f and g are function with the domain a intersection b. Right? So a is the domain of f, b is the domain of g. If you add the two functions together, if you subtract them together, if you multiply them together, your domain gets smaller. Because as you satisfy both at the same time. Here are some properties. F plus g of x is equal to f of x plus g of x. This is due to the linearity of the function. I'm not going to prove it here. This is from like proven math, like 300 level math. You just have to take face value here. On the exam, I'm going to write like this. That's how I write it on the exam. I suggest you're supposed to break it down like the right hand side. I suggest you break it down like that. Which one you like more? The right hand side or left hand side? Which one more friendly to you, to your eye? The right hand side, right? I see one function and then the other function. All I do is just add them together. On the left hand side, it's a little bit more abstract. But that's how I'm gonna write it on the exam. And then and then you're supposed to break it down like that. Same thing with the minus. Same thing with the x times g of x. Now, f divide g of x is a little bit different. If you rewrite it, it'll be f of x divided by g of x. The domain is still this intersection between a and b plus whatever in the denominator is going to be 0. Right? So a bit more tricky because of rational function. You want to write that down if you have it? Because I'm going to go to the problem. Here it is. Given f of x is square root of x minus 1 and g of x is 3x plus 1, find the domain of f of x. Ooh, we did this last time. The domain of the even radical. And it's on the top. It's on the top, right? Can someone remind me what it is? Do you remember? Let me go back. Go back to 2.3. The domain of the no, that's odd. Right here. Even radical function, you set the radicand is very equal to 0, right? So whatever underneath the radical is at least 0. Make sure you know those, so those on your final as well. So that means the domain for f of x, we call it the set A, is let me do on the scrap paper here. I mean, x minus 1 has to be greater or equal to 0. That's imply x greater or equal to 1. And of course, I want you to write it in interval notation. I don't want that way. So interval notation will be what? From 1, right, to infinity. 1's included, so we use bracket. Why don't you do b? Why don't you do b? Very good, because why is that? What kind? Yeah, very good. Polynomial functions are very easy going. If you look at their graph, it's smooth everywhere. No gap, no hole, no jump, no sharp corner. Right? In calculus, we call that continuous, which is very important. So everything. So what's the domain of A intersection B? No, intersection is gonna be smaller. If you doubt yourself, you can always draw it out. 1 is included, so I'm gonna use solid dot. For the domain of set A, it's from 1 to infinity, right? For set B is everything. So what is intersection? Where's the darker darker 1 to infinity, right? Do you understand it now? Yes.
Can you explain that one more time?
So domain of A intersection B is going to be the portion where they intersect. So if you graph it, if you are visual people, graph it. So for the first one, for the first domain A, is go from 1 to infinity, right? For the second one is everywhere. So where the intersection, where the darker shade, right, which is 1 to infinity. F plus g of x. Again, I would recommend you write like this on the exam. So that means the square root of x plus minus 1 plus 3x plus 1. Am I done there? Can I simplify more? Can I simplify more or I'm done? Can I cancel the 1 and negative 1? Can you cancel that one with that one? No, right? I know it tempted, but this is two different words, right? This is radical words, this is polynomial, right? They're two different things. So you leave it like that. And there's no property that allow you to split this up either, right? Because the plus and minus. Right? That'll be your answer. F minus g of x. So f of x minus g of x, the square of x minus 1, minus, tell me this is right or wrong. I'm showing you all the luck. Huh? It's correct? Who said correct? Just raise your hand. Correct. Wrong? Wrong. What about the rest? This is a common mistake you didn't make. I'm sure that is you don't make it by, on purpose. It's just an exam, you're nervous, right? When you subtract a function, I would put the parentheses around it, right? So the negative go for everybody, not just the 3x. You cannot distribute that negativity. So square of x minus 1 minus 3x minus 1. Then we're done. F times g of x. That means f of x multiply g of x. So that means square root of x minus 1 multiply 3x plus 1. I want you to think this as one term. Not split it. Let's distribute square root of x minus 1. Square root of x minus 1 times 3x. Can I bring 3x to the front? Okay. And write like that. And then plus 1 times square root of x minus 1, which is 1 times square root of x minus 1, which we don't write the 1, so we erase that. Now we're done. Last one. F of x divide g of x. I mean f of x divide g of x. That means square root of x minus 1 divided by 3x plus 1. There's nothing we can simplify, but there's something else we can do. What else do you think we should do? It's something about the domain. Yeah, right. So in addition to the domain that we had above, there's more, right? There's one more, which is the denominator cannot be 0, which is this right here. Maybe I'll use your dark green. So 3x plus 1 cannot be equal to 0. Thus imply x cannot be negative 1/3, right? Lucky for you, negative 1/3 is right here. So it's already outside. It's already outside. So for this problem, if you don't do anything, you still got 4 points because you got lucky, because negative 1/3 is outside the original domain. Now, if I would have changed this into a minus, 3x minus 1, and that's result in positive 1/3, then your new domain will be that domain. What else? Plus x cannot be 1/3, right? Yeah. So be careful with the division. Belong to 1 infinity, so we're good. Okay. Any question from this problem? Oh, not belong. Remember that little funny e, epsilon in Greek? If it epsilon or a little funny e, then it mean belong to. If you cross that, it mean not belong to. It's kind of like equal, and then you cross that, it's not equal. Negative 1/3 is not inside the interval, so we okay. We don't have to eliminate anybody. All right, application. You guys are business people. You probably help me with this. Suppose Puritron, a manufacturer of water filter, has a monthly fixed cost of 10 grand and a variable cost of this function, negative 0.0001 x squared plus 10x, where x denotes the number of filter manufactured per month, and it's between 0 filter and 40,000 filters. That's your domain. Find the function c. Here in this class, the capital C denote for the function of cost, c of x. Find the function c that give the total monthly cost incurred by Puritron in manufacture of x filters. All right, so cost. Say you're a CEO, you want to find how much cost to manufacture X filters. The first thing you tell me how much you have to put the payment down. What the fixed payment? 10 grand, right? That's your fixed monthly payment. And what the variable cost? Depend how many filter you have, depend how many filter you are doing. That's your variables, right? That's your variable, your another cost. So negative 0.0001 x squared plus 10x plus 10,000. Don't forget x is between 0 and 40,000. We done for part A. Do you have any question for that part? No. Every month you pay 10,000 plus every filter that you accepting, that you doing, that's your another cost, right? So one filter, you plug it in. If you do one filter, I don't know why you do one filter. One filter, you plug in 1 for X, 2 filter, 3 filter, up to, you only allow up to do 40 filters per month, right? 40,000 filters per month. So that's your cost. How much you pay for running each filter or X filters. Suppose the total revenue in dollars realized by Puritron from the sale of X water filter per month is given by the total revenue function. Can someone tell me what revenue means? Yeah, how much money you bring in, right? Before the cost. Right? You business people, you know. So revenue mean how much you bring in. Before the cost and everything, just how much you make. Before the cost. You don't have to write that, it just remind you. Now find the profit function. That is the function that describes the total profit that the company is making by selling X water filters. Oh, they selling filters, they're not doing filter. They're not services, they sell stuff. All right. Do you agree that profit is equal to revenue minus the cost? Yes. Right. Do you know revenue? Yes, right. You have the function for revenue. You have the function for cost right here. You plug it in. Let me rewrite this in with the X. So P of X, profits equal revenue minus the cost. You plug it in. Negative 0.0005 x squared plus 20x minus, careful, minus, you're gonna have the parenthesis. What the C function right there? So minus 0.0001 x squared plus 10x plus 10,000. That is revenue. That is cost. Excuse me. Simplify. Negative, they have the same zero here, name number 0. So negative 5, negative 1, that's negative 0.0006 x squared. 20x minus 10x, that's 10x. And minus 10,000. That will be your profit function. Oh, I keep doing that. Not in the domain. It's a good habit to have. If there is a good habit to remind yourself, like, what is my allowance range? The domain. Extra currency. Yes, yes.
Wouldn't that be plus 10x minus 10x?
Oh, plus 10x, yeah. I see plus 1 by 9 minus, sorry. Thank you. No, thank you. So what you have is, yes.
I was gonna say, shouldn't it be negative 0.001 x squared? Why was it positive? Was the answer above negative?
Oh, this is sorry. Yeah, you're right. I didn't, all right, sorry, thank you very much. There's a negative here, I forgot to bring it with me. Let the other side all correct. Thank you very much. So that'll be negative 0.04, right? Yeah. Yeah, that's what I have on my notes. Oh, it's making me nervous so that I see it to be wrong. But my note is right, so the extra credit is right. Positive 20x minus 10x is 10x. You have 2 attempts. Give me a second, right? Okay. All right. Okay. So calculating. Let me tell you a calculator you can use on your phone. Either you can download this right here, like right on the sorry, it's lagging. You can calculate 84, or you can use decimal. There's a decimal calculator. I think it's called. Do I have it here? I have it on my phone. Let me check. Decimal test. Let's see, decimal test mode. So you go to apps here. Come on. Come on. So test mode here. Decimal test mode. Right there, the one in blue. If it was up to me, I would let you use that on the exams because it lock. Once you start, because that's for exam. When you start the exam, there's a lock mode that allow me to lock it with your phone. So it count the time you start like using it, right? If you go to message or go to Safari, the time will stop. So I know that you did, right? So it's you for exam, but they don't allow me let me use it. So too bad. I taught technology now that everybody use the phone for everything. Notation. Okay. All right. For objective 2, we're gonna talk about composition of function, a function inside a function. So far what I did was I added 2 functions together. I subtract them, I multiply them, I divide them. We even have an application problem that do that. Now, what if I want to solve one problem inside another problem? Like, think of like Russian doll, those funny looking doll that you have a big doll and then inside you have a smaller one, inside a smaller one, kind of like that. So that's what we're doing. We put one function inside another, right? And that's called composite function. If you see something like G parenthesis f of x, you can read it as G of f of x, or you can read it as G composite of f of x. Another funny looking notation for composite function is this. G, and then little dot, little funny dot, F of X. It's not multiplication, okay? Multiplication actually do one solid dot. Here you have a hollow dot, it means composite. On the exam, that's how I write it. And your job to be be able to interpret it, what does that mean, right? So that means G of F of X, if I write like this, then what does that mean? F come first, right? F the outside function, right? G the inside function. So F come first. F and then inside would be G. So on the exam, that's how I write it. I use the notation. Your job is to use a different notation. Not because I'm mean, because in mathematics, everywhere you go on the exam, that's how they use it. I just try to get you used to it. Should be F here, that's F, not D. Right. Let's talk about the domain of G composite F or F composite G. But let's just take one case because they're the same. Let's just take one case. What G composite F mean? This mean G is the outside function, right? And the inside function is your F of X. Let me draw a picture for you. Here's I have my value X. Here's my machine F. And here's my machine G. The input X, I'm going to put in the machine F. Put that in machine F. You get what? What the result? F of X, right? Your product is F of X. So your product, let me make this to blue. Your product is F of X. And then once you have the product, when you have your product F of X, what do you do next? You shove it into the G function, right? The G machine. So you F of X, go there. Now you have what? G of F of X, right? You have G outside, and then inside there's F of X. That's your result. So here you can see that, remember domain is all the X values, right? All the inputs. Domain is the input. So the domain for the machine F is all the X, that make F defined, right? And what's the domain of G? The domain of G is, well, you ask yourself, what's the input for G? Well, the input for G is no longer X. It's the whole function F of X, right? So the domain for G is the input F of X. Just for understanding, I'm not gonna test you on that. Let's take a look at the example. This is more like your exam here. Given f of x equal 3x minus 5, g of x is 2 minus x squared. They both polynomials, so we don't have to worry about the domain. It's all real number. Phi f composite g of -1. If I was you, I would rewrite this before I do anything else. Space. This will be let's say this will be a blue function and f will be red function. Let's use color so you can see it. What would I do first? You're gonna do from inside out, right? Inside out. So let's expand that out. So inside is g of -1. So you plug in -1 for the blue machine, right? For G. The blue machine is 2 times x squared, rather parentheses square, and then you replace with the x with the -1. So far, so good. What is equal? 2 minus quantity of -1 squared equal 1, right? -1 squared is positive 1, 2 minus 1 is 1. So now g of -1 equal 1. Remember, you still have the outside function. Now, you plug in 1 for f, right? For f. That's the input of f. F is 3 times x minus 5, and x here is 1. -2. So your final answer is -2. That's your final product. Is a good, if you have question, it's a good time to ask now. You see something like this on the exam, I promise. So you always do from inside out, right? You just from smaller function to the larger function. So first I plug -1 for G, and then I calculate what it is. Once I have that value, I plug for F, and then I have my final answer. Why don't you guys do B? I'll walk around, see how you do. Rewrite it. I would rewrite F, the little circle F, -1 to do what I did right there. Which one, the outside function, which one the inside function?
Yeah, I was trying to.
to find the answer. So I would suggest you always rewrite it. It's really help. Bless you. So I'm gonna calculate the one inside first, right? So the f outside, I'm gonna rewrite so I don't forget. F of -1, plug in -1 for x. So I see 3 times -1 plus 5. Bless you. That's f of -5, sorry, -5. So that's f of -8. And now you plug in back again, right? 3 times -8 minus 5, -24, -5, -29. You guys get an idea, right? And because you do, I want you to do 2A for your extra credit. You need help, let me know. Hey, hang on. Something wrong. Hang on. All right, something wrong. I give you a different problem. Darn it. Oh, I messed up. I messed up. Oh, I messed up. Oh, that was your extra credit was supposed to be this one, 1A. I put the answer 1A for extra credit number 2. Yeah, -2 is your answer. It was I bought the wrong one, sorry. All right, we do together on that one. Let me remind myself to fix, so I fix f of for next semester, not for you. F of g of 3. All right, g of 3, g is something square minus 4, and that something now will be 3. 9 minus 4 is 5, so that'll be f of 5. Plug in 5 for f. So 1 over square of 5. If you want to be, if you want to impress me, you can do square root of 5 over 5. It's the same thing, right? Rationalize the denominator. Mathematicians don't like radical in the root and the denominator. that what you got? Okay. It meant to be 2a, but then when I do the I set it up, I look at the different problem. All right, what if I don't give you the exact value? What if I just say plug in f of x into g or plug in g into f? Generally, right? We do the same thing, right? We do the same thing. So let's rewrite this. It's gonna be f, well, g is the outside function. It's gonna be g of f of x. What's f of x? 1 over square of x, right? Whatever they ask you to do, just do it. It's like I said, math is all pattern. It's the same thing. That means what? Now the input for g is no longer x, it's 1 over square root of x. Now you're gonna plug that for the function g. And the function g, I would recommend you replace the x with this parenthesis. Now, plug it in. 1 over square root of x squared, that's 1 over x minus 4. And you can leave it like that, or if you want, you can bring it into one fraction. It doesn't matter, it's the same thing. Let me show you. Actually, you can do this on the decimals. So there I have my function f up top right there, and then my function g. Now I want to put f in g. So let's more graph the orange graph for us right there. My answer is 1 over x minus 4. Now I have to put the domain because x cannot be what? Oh, it has to be greater than 0, sorry. It cannot be 0 either. But check it out. That's your answer. If it match decimals, then you know that you got the right answer, right? You can check your answer, you can do your homework like that. Last one, and we'll call it a day. Last page. Talk about inverse. If f of x is square of x plus 1, can someone tell me what the domain of f of x? Should be pro by now. It's not polynomial, careful, it's not polynomial. Whatever underneath the radical has to be what? At least 0, right? In this case, just x under the radical, so x had to be greater or equal to 0. And then g of x is a polynomial function, x minus 1 squared, where x is at least 1. I want you to show that f composite g is the same thing as g composite f, and they both equal to x. Let's do that. Let's see. F of g of x. What g of x? G of x is x minus 1 squared. Now I'm going to plug that for f. F is square root of that plus 1. And the square root of your new x will be x minus 1 squared. What's the square of x minus 1 squared? Thank you. X minus 1. And then plus 1, which is x, or x. Cancel. So the answer is x. Let's do the other way around. Let's do g composite f of x. Now you plug in F inside G. F is square root of x, f to 1. Now I'm going to plug that for G. All right, so the new x here is going to be square root of x plus 1. Can I simplify the 1 and the negative 1? Huh? Why not? Yeah, the square root stop right here. Yeah, careful. Yeah, careful. Oh, yeah, be careful. You can, in this case you can because it's not belong to the root. Square of x square, which is x. Look at that. Now, when you have something like this, f is the inverse of g, or g is the inverse of f. So your conclusion is f and g are inverse. Let me rewrite the word inverse for you. Of one another. Sometimes they call g is f of -1. It's not to the -1. Do you guys remember that? Do you remember that inverse notation? Yeah, I remember that. So when you shoving thing between two functions that are inverse, you answer always x, no matter what your function are, as long as they inverse. I still have 4 minutes, and for the last 4 minutes, I'm gonna use decimal. If you want to take it from me? Okay, together with the straight line y equal x. Let me mute that. So that's my first one. That's f and that's g. And this is y equal x. What do you see? What? Huh? Yeah. What can for your just from your general knowledge, when you see that picture, what do you see between the green and the orange? They kind of like mirror image of each other, right? If you flip the green, over the y equal x, you match up with the orange, right? And then vice versa, right? Now let's check it out. Their point. There's 0, 1, and then 1, 0. Are they x and y switching? 1, 2 for green, and 2, 1. Look at that. They are mirror image of each other. One more point. 3, 4, and 4, 3. Well, it's all the way up here, but you can see the range and domain are switching. So for inverse function, what do you see? They are symmetric about the y equal x. What else? Domain and range are flipping, switching. Right. So that's 2 things you remember. Let me write down real quick, and then you get to. Are symmetric about and lagging, and their domains range are swap. Done. The little box means I'm done. All right, have a good one. I'll see you again on Wednesday, one way or another.